Hi guys, welcome back to In Case of Econ Struggles. Today I'm going to keep talking about econometrics. I'm going to talk about hypothesis testing. I'm going to talk about hypothesis testing pretty broadly. What I want you guys to do is I want you guys to go into the comment section and I want you to comment which type of hypothesis testing you had the most trouble with. Could be t-test, could be f-test, just whatever type of hypothesis testing you struggled the most with. And I'll use that to sort of decide what sort of hypothesis testing I talk about in which order. But for now, timestamps are below if you would like to jump around, but let's go ahead and get right into it. I'm going to talk about hypothesis testing through an intuitive example. So maybe you're Bill, and maybe Bill and Shanique are arguing, and Bill says, I think on average cats weigh about 15 pounds. Shanique says, I don't think that's right. I think you're wrong. I don't think cats weigh on average 15 pounds. We're trying to basically find a more formal way to test whether Bill is right or not. And so maybe you have the sample of cats. You've got 100 cats, and you've got their weight. Their average weight is 20 pounds. The variance in those weights is 4 pounds. And so if I think about the standard deviation, which means that the standard deviation here would be 2, then x bar plus 2 times the standard deviation is 22. And x bar minus 2 times the standard deviation is just going to be 18. And so again, we're trying to use this to think about who is right or not. And we're not allowed to Google and figure out what the actual average weight of cats is. Because oftentimes when we're doing this hypothesis testing, we don't actually know what the true answer is. So by not Googling, we're basically saying we can't know what the true answer is. We're just trying to figure out who's right or not based on this sample of 100 cats. And so all we're going to do is we're going to put more formal language on this sort of argument between Bill and Shanique. Where Bill says, I think on average cats weigh 15 pounds, we're going to call it H0. That's going to be the null hypothesis. The null hypothesis means that the population average of cats, or mu, is equal to 15. You can have a lot of different null hypotheses, and again, that'll change depending on what sort of hypothesis testing we're talking about. But in this basic example, the null hypothesis is that the average weight of cats is 15. Shanique is going to say that she thinks Bill is wrong, and so that's what we're going to call H1 or HA. That's the alternative hypothesis. Here we're saying that mu, or the average weight of cats, is not equal to 15. Again, your alternative hypothesis is going to differ based on the exact type of test you're running. But just for now, just saying Bill is wrong, we're saying that the average weight of cats is not 15. And now what we need to do is we need to find a way to use this sample in order to answer the question of whether Bill is right or not. So basically what we're going to do in any hypothesis test is we're going to say, okay, if we assume the null is true, we're going to find a distribution of this variable or of this thing we're talking about. We're going to use that distribution and we're going to look at this distribution under the null. We're going to look at this distribution and we're going to look at where our value of the sample falls relative to that distribution. We're going to use that to answer the question. So here, for example, we're talking about the weight of cats. Maybe we'll just assume that the null is true, and so the distribution of the weight of cats is centered around 15. And maybe we'll also assume that it's a normal distribution. We don't have to assume it's a normal distribution. When we talk about other types of hypothesis testing, the type of distribution will change. But here, a normal distribution sort of makes sense, and so we'll use a normal distribution. Now, our sample mean, our average weight of cats was 20, and so that's going to be at this purple line right here. And you can see that what we've got is our mean plus or minus 2 times the standard deviation was 18 and 22. And so what we're going to say is we're going to say, okay, this is where our sample fell, and this is our 95% confidence interval for that sample. Now, if I think about a 5% test, and we'll talk about levels of test in a minute, but if I think about a 95% test, this red line is basically saying if our sample is to the right of this red line, then what we're going to say is, well, it's probably not the case that the true average weight of cats is 15. It's probably more likely that the true average is not 15, and so that would indicate that Shanique is right, and Shanique is right, meaning that Bill is wrong, and that the average weight of cats is not 15. And so basically what we did is we calculated the distance between the average in our sample and the average under the null hypothesis, assuming that the null was true, which was 15. And then what we're going to say is we're going to say, okay, well, we need to scale this distance. We need to scale this distance based on how much variation there was in our sample. And in our sample, there was only a variance of 4. Say this sample variance was bigger. Say this sample variance was equal to 25. Well, if it was equal to 25, then this orange bar would basically be at 10. And so this is 10 right here, and you would see that that confidence interval would span 15. And so we wouldn't be able to say that Shanique is right and Bill is wrong, because if that 95% confidence interval goes over the mean with the null, well, we can't reject that it's likely that the average weight of cats is 15. And then we also, because we're doing a sample, we're going to scale it by the number of observations in the sample. And so we calculate this scaled distance, and I'll talk about this again when we talk about t-tests, but we basically scale this difference between the sample average and the average under the null hypothesis. We're going to get this z-score, which in our case is 25, and we're going to compare this to our critical value, which we're going to get from a lookup table based on the type of test we're doing, based on the number of observations. And so if we did this based on a z-score, this will be 1.96, and our value exceeds that 1.96. And so what we would say is we're going to reject the null hypothesis. We're not going to say whether the alternative is right or not. We're just going to say that we reject the null, or if in this case, suppose we got a number differently, and suppose our number was like 1.4. Well, 1.4 is less than 1.96, and so we would not reject the null. We would not necessarily accept the null. We would just say we don't reject the null. So just to make that a little more general, in any hypothesis test, we have a null hypothesis and an alternative hypothesis. What we're going to do is we're going to first assume that the null hypothesis is true, and then we're going to assume some sort of distribution of our variable. Again, we're going to use the assumption that the null hypothesis is true when we make that distribution. Where we're going to get that distribution, we're going to figure out, based on our sample, where our sample falls on that distribution. We're going to calculate a critical value, basically for our sample size, for whether or not we're doing a one or two-sided test, and what type of distribution we're talking about. And then we're going to evaluate the scaled difference between the data and the null hypothesis. That's going to tell us whether we reject the null or whether we do not reject the null. So again, please comment below if there's a specific type of hypothesis test you want to see me cover. I'm going to cover t-tests. I'll cover some other basic ones as well. But again, if there's a specific hypothesis test that a lot of people want to see, I'll definitely prioritize you making that video. But if this video or these videos in general are helping you out, please like and subscribe. We'll see you next time for another case of econ struggles.